All right, guys. So now we're going to get into graphing all of the other trig functions. Okay. So I'm going to start with this slide over here, where we're going to consider this, which is considered the reciprocal function. Okay, and you saw this probably in Algebra 2, but it's been a little bit. So let's think about this. Okay, if I were to put 0 into the reciprocal function, I would get something that's undefined. And if you think back to Algebra 2, that would have created an asymptote. Okay? Clearly, if I put in 1, I get 1. If I put in 5, I get 1/5, which is 0.2. If I would put in 10 in the denominator, I would get 0.1, well, 1/10, which is 0.1. And then I would get 1/50th, which is 0.02, and 1/100th, which is 0.01. So as these get bigger, okay, as they tend to infinity, these are getting smaller and smaller. Okay? And eventually they're going to tend towards 0, but they're not actually ever going to get to 0. Okay? So now, if I would do the same thing here, put in 0, I get undefined, which would create an asymptote. If I would put in 0.9, okay, I'm going to get 1.1 repeating, 1.43. If I would put in a 0.5 in that denominator, I would get 2, 10, 100, 1,000. Okay, so as these get smaller, so as these are tending towards 0, these are getting bigger and tending towards infinity. So keep that idea in mind as we start to graph the secant and cosecant function. All right, so let's come over here and let's lay a little bit of the groundwork for cosecant. So first of all, recall that cosecant is the reciprocal of sine, so 1 over sine. Okay, so let's remember that these are reciprocals. Okay, so let's start by thinking about sine first. Okay, so if we would talk about what's happening here, we don't have any vertical horizontal shifts. Our amplitude's technically 1. We don't have anything really going on. And I'll show you in a later example what we do if any of those things occur. But let's talk about the chart that would occur for sine. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi. The values for sine would be 0, 1, 0, -1, 0. So now let's think about the values for cosecant. Because remember, they are reciprocals. Okay, so if I take 0, technically if you want to make that 0 over 1, and I take the reciprocal over that, I'm going to get something that's undefined, which would create a vertical asymptote. So anywhere where I have 0, we're getting undefined, which creates that vertical asymptote. Okay? Now, if you take the reciprocal of 1, it's 1 over 1, flip it, you still get 1 over 1, you still get -1 over 1. Okay, so what I'm going to do first is I'm actually going to graph my sine function first. So you can see what's happening here. So if I plot sine, I'm going to do it with a dashed line. Okay, it would look like this. Now remember, like I said, they are reciprocals. Okay, so at 0, I have this vertical asymptote. Same thing at pi and at 2 pi. Okay, because the value came out to 0, so if you flip that, you get something undefined. Now, I'm still at 1 here, and I'm still at -1 here. But what's happening in between here? So let's come back to this idea that we looked at the beginning slide. Okay, if you're going this way, okay, your y values are tending towards 0. Okay, for sine. So if we take the reciprocal of that, if the y values are tending towards 0, okay, then the reciprocal would be tending towards infinity. Okay, they're going to kind of work opposite there. Same thing here. These are heading towards 0 just from the negative direction. So if you take the flip of that, now they're going to be heading towards negative infinity. And you could, by all means, calculate more of these in-between values for the sine function and then take the reciprocal of those, and you would get values up in here. But it's always going to work like this. They're going to create kind of little parabola-esque looking shapes in between those asymptotes. And this graph, this is just one period of it. If you would keep going, you would see more of these little like U shapes. So let me show you real quick in Desmos. So this is what sine looks like. So if I bring in cosecant, you can see that you would get these alternating U-esque shapes. Okay? Okay. Now let's talk about what's happening here in terms of our domain and range. Okay? So our domain has all these asymptotes. So there's a lot of values where x cannot exist. Okay? So we're going to say that it can't be the first vertical asymptote plus 1/2 of your period, k, where k is just some integer. We saw that k like the very, very beginning of trig. Okay, so for this one, here, this, or not. Okay, so for this specific function, we're going to say that x cannot be the first asymptote is, and you can see it from our table here, is occurring at 0 plus 1/2 of our period. Well, our period here was just the standard period of 2 pi, so half of that would be pi. Let's think about it. Okay, the 0 occurred again at pi, and then again at 2 pi. So the second time it occurred was halfway through the period. Okay, and then it keeps recurring every time you put a different k value in. So k is some integer. So if I would put in 1, 0 plus 1 times pi would just be a pi. If I would put in 2, if I would put in 3, if I would put in -1. So if you would take this graph in the other direction, kind of like we saw in Desmos, you'd have asymptotes over here at -pi, -2 pi, etc. Okay? Now our range, think about this. Sine was from -1 to 1. Cosecant is everything outside of that. Okay? So if you always go from smallest to largest. So the smallest value would be -infinity up to -1 and including -1. And then it skips over everything in between there and it picks back up here at 1 and goes to positive infinity. Okay. Now let's talk about secant. So it's going to be very, very similar, but it's the reciprocal of cosine. So recall that secant x is 1 over cosine x. So if I make the chart for cosine, whoops. Okay, so cosine was 1, 0, -1, 0, 1. Okay, so remember that they are reciprocals. So let's do the chart for secant. So similar to before, with the sine and the cosecant, anywhere that you had 0, you take the reciprocal of that, it's going to be undefined, and you have a vertical asymptote. Okay? So now, if I flip 1, I get 1. If I flip -1, I still get -1. So let's come over here. I'm going to do a dotted curve for cosine, just like I did before. So it would be 1, 0, -1, 0, 1. Oops, shoot. I forgot to make it dashed. Okay. Okay, so now for secant, my first asymptote here, you always want to draw in these asymptotes first, is at pi over 2 and then 3 pi over 2. Now, at 0, it's still at 1. At pi, it's at -1, and here it's at 1. And what's going to happen here, similar to before, okay, here cosine was heading towards 0, so secant, its reciprocal, is going to head towards infinity. And that should be more curved. Sorry, not like straight-esque. Same thing here. These were heading towards 0, those y values. So for the reciprocal, the y values will be going towards -infinity. Same thing here. So this, if you would look at this guy, so here's cosine. Okay, here's your standard cosine. Okay, so if I bring in secant, we are just seeing in our graph this little portion, this guy, and half of this portion. There is more to it. We're just seeing from here to here, basically. So these guys are getting cut off. but they do exist. They would keep going there. We're just drawing the the section from 0 to 2 pi for right now. Okay, and those would keep going on and on forever in both directions. So now let's talk about our domain and range. So for this guy, same as before, you would say that x cannot be, okay, your first vertical asymptote plus, same thing, half your period, k times k, where k is some integer. So we would say it cannot be. Our first asymptote in this one is at pi over 2, and then it occurs again. Your period in this guy was 2 pi, so half of that period is just pi k. If you would put in 1, you would get that 3 pi over 2. If you would put in 2, you would get that the next asymptote's 5 pi over 2, etc. And your range here is going to be the same idea as cosecant, negative infinity to negative 1, because that's where that red graph exists. And then it picks back up at 1 and goes up to infinity. Okay? Now, in the next video, just because I'm short on time, I'm going to go through 2 examples that actually have transformations done to the graph. Okay?